Picture this. It's October 19th, 2017. An astronomer, Robert Warrick, is scanning data from Mahala Observatory in Hawaii. The night sky, captured in pixels and numbers, streams across his monitor in routine patterns, until something extraordinary catches his eye. A single point of light, moving with impossible speed and trajectory through our solar system. This wasn't just any space rock. What Warrick discovered that night would challenge everything we thought we knew about visitors from the stars. The object was unlike anything in our cosmic neighborhood. Stretching roughly 400 meters long, but only 40 meters wide, it tumbled through space like a cosmic cigar, reflecting sunlight in ways that defied easy explanation. Scientists quickly realized they were looking at something that had traveled for millions of years through the void between stars before arriving at our doorstep. They named it Aomau'ua, Hawaiian for scout or messenger from afar. But here's where things get interesting. As Aomau'ua raced past the sun and began its journey back into interstellar space, it did something that shouldn't have been possible. It accelerated. Not the gentle push you'd expect from solar radiation, but a measurable, consistent acceleration that had no visible cause, no tail of gas or debris. No comet-like outgassing. Just smooth, unexplained acceleration away from our sun. The scientific community erupted in debate. What could cause such behavior? Some proposed exotic ice compositions or internal gas pockets invisible to our instruments. Others suggested more intriguing possibilities. Dr. Avi Loeb from Harvard dared to voice what many were thinking, but few would say. Could this be artificial? Could we be looking at technology rather than geology? The questions multiplied faster than the answers. Why was it so elongated? Why did it reflect light like polished metal? Why the mysterious acceleration? And perhaps most unsettling of all, why did its trajectory seem almost perfectly designed for a close encounter with Earth? Before the scientific community could reach any consensus, Aomau'ua disappeared into the cosmic dark, leaving behind more questions than answers and a profound sense that we had missed something monumental. But the universe, it seems, wasn't finished with us. Fast forward to 2019, and another interstellar visitor arrived. This time, the Atlas survey system caught it early. They designated it 2I Borisov, and unlike Aomau'ua, this one behaved exactly as comets should. It outgassed, it had a proper tail, it followed predictable physics. The relief was almost palpable. See? Interstellar objects are just exotic space rocks after all. Except. There was a third visitor, one that would make Aomau'ua look ordinary by comparison. In late 2023, ATLAS detected another object on an unmistakably interstellar trajectory. The preliminary designation, 3I-ATLAS, and as data poured in from observatories around the world, a chilling pattern began to emerge. The acceleration anomaly was back. But this time, it wasn't a 1.3/Atlas. Displayed characteristics that pushed the boundaries of natural explanation even further than its predecessor. Its surface composition defied spectral analysis. Its rotation was eerily stable, and most disturbing of all, its approach trajectory suggested something that made seasoned astronomers pause in quiet contemplation. It seemed to be steering, not the chaotic tumble of a rogue asteroid or the predictable arc of a comet, but the controlled approach of something with purpose, something that had traveled across the vast emptiness between stars and arrived exactly where it intended to be. Two visitors in less than a decade. Two objects that challenged our understanding of what should exist in the cosmic void. Two mysteries that shared unsettling similarities and raised a question that keeps astronomers awake at night. Are we witnessing the beginning of contact? As 3I Atlas continues its approach toward the inner solar system, every major observatory on Earth has turned its attention to this enigmatic visitor. Radio telescopes listen for signals. Optical arrays track its every movement. Spectroscopes analyze its impossible surface composition, because if Oumuamua was a scout, if 3IATLAS represents the next phase of something larger, then we may be living through the most significant moment in human history without even realizing it. The age of cosmic solitude may be ending. The question is, are we ready for what comes next? When 3IATLAs first appeared as a faint smudge on the Atlas survey cameras, it looked like nothing more than another piece of cosmic debris. But as astronomers calculated its trajectory, something remarkable became clear. This object had originated from outside our solar system, traveling through interstellar space for potentially millions of years before arriving in our cosmic neighborhood. The Atlas network, a sophisticated early warning system designed to detect potentially hazardous asteroids, had stumbled upon something far more extraordinary than a typical space rock. Dr. Sarah Chun at the University of Hawaii's Institute for Astronomy was among the first to analyze 31ATLAS's orbital characteristics. The moment we plotted its trajectory, she recalls, we knew we were looking at something special. The hyperbolic orbit was unmistakable. This thing came from another star system, but determining interstellar origin was just the beginning of the puzzle. As observatories worldwide trained their instruments on 3ITLAS, a series of anomalies emerged that echoed the mysteries of Oumuamua while presenting entirely new questions. First, there was the acceleration anomaly. Just like its predecessor, 3I Atlas exhibited a steady, measurable acceleration that couldn't be explained by solar radiation pressure or conventional outgassing. But unlike Oumuamua, which showed a relatively simple acceleration pattern, 31ATLAS displayed what can only be described as controlled course corrections. The object's trajectory would shift by tiny amounts, fractions of a degree that required precise measurement to detect. These weren't random perturbations caused by gravitational influences or solar wind. They were systematic adjustments that followed a pattern. Dr. Marco Vestri from the European Southern Observatory captured the growing excitement in the scientific community. We're seeing behavior that suggests active navigation. It's subtle, but it's there. Something is adjusting this object's path. But spectroscopic analysis revealed even more puzzling characteristics. While Oumuamua had shown unusual reflective properties, 31ATLAS presented a surface composition that defied classification. The spectral signatures didn't match any known asteroid or comet material. Instead, they suggested a complex metallic composition with properties that seemed almost engineered. Reflectivity patterns are unlike anything in our database, explains Dr. Elena Kostova from the Max Planck Institute. It's not just unusual, it's impossibly consistent. Natural objects don't maintain such uniform surface properties across their entire visible area. The rotation characteristics added another layer to the mystery. Most asteroids tumble chaotically through space, their rotation patterns influenced by collisions, gravitational encounters, and thermal effects over millions of years. But 3IATLAS rotates with mechanical precision, a steady, controlled spin that maintains perfect orientation relative to its trajectory. This controlled rotation has profound implications. It suggests that either 3IATLAS has some internal mechanism maintaining its stability, or it's been deliberately designed with this characteristic in mind. The size and shape analysis, conducted using radar observations and light curve measurements, revealed proportions that echo Oumuamua's elongated profile, but with even more extreme dimensions. The length-to-width ratio suggests an object optimized for interstellar travel, minimizing cross-sectional area while maximizing surface area for solar radiation collection or communication arrays. But perhaps the most intriguing anomaly is what scientists are calling the communication window phenomenon. During specific periods of 3IATLAS's rotation, sensitive radio telescopes detect structured electromagnetic emissions, not random noise, but pattern signals that repeat with clockwork precision. These emissions are incredibly faint, right at the threshold of detectability, but their regularity suggests artificial origin. The patterns don't match any known natural radio sources, and their timing correlates perfectly with the object's rotation and trajectory adjustments. Dr. Raj Patel from the Arecibo Successor Facility describes the discovery. We're seeing organized electromagnetic activity that coincides with the object's navigational corrections. The correlation is too precise to be coincidental. When compared directly with Oumuamua's characteristics, the similarities become even more striking. Both objects share extreme elongated proportions, unlike natural asteroids, unexplained acceleration without visible outgassing, unusual surface reflectivity patterns, approach trajectories that brought them unusually close to Earth, spectroscopic signatures that don't match known solar system materials. The statistical probability of two such similar objects appearing in our solar system within a 6-year period is extraordinarily low. Dr. Amanda Torres from MIT's Haystack Radio Observatory calculated the odds. If these are truly random interstellar objects, the probability of encountering two with such similar anomalous characteristics is less than 1 in 10 million. This statistical analysis has forced even the most conservative scientists to consider alternatives to purely natural explanations. The directed panspermia hypothesis, the idea that life spreads through the galaxy via artificial means, has gained renewed attention. Under this scenario, objects like 3I Atlas and Oumuamua could be automated probes designed to study or even seed promising planetary systems. The probe hypothesis, once relegated to science fiction, now finds itself discussed in peer-reviewed journals. Dr. Loeb's research team at Harvard has published detailed analyses of how advanced civilizations might design interstellar reconnaissance vehicles, and the predicted characteristics match many of the observed anomalies, but the implications extend beyond individual objects. If 3I Atlas and Oumuamua represent artificial probes, then we must consider the possibility that our solar system is under systematic observation. The objects could be part of a larger network, with dozens or hundreds of similar probes operating throughout our cosmic neighborhood. The timing is particularly significant. Both objects appeared during humanity's rapid advancement in space technology and radio communication. Could this be coincidence, or are we witnessing a coordinated observation campaign designed to assess our technological development? As 3I Atlas continues its approach toward the inner solar system, astronomers race to gather more data before it follows Oumuamua into the interstellar void. Every observation brings new questions, new anomalies, and new possibilities that challenge our understanding of what should exist in the space between stars. Evidence is mounting that we're dealing with something unprecedented. Whether artificial or natural, these interstellar visitors represent phenomena that push the boundaries of known physics and force us to expand our concepts of what's possible in the cosmos. The question that haunts every astronomer working on this puzzle is simple but profound. If we're being watched, what happens when the watchers decide we're ready for contact? The decision to actively listen for signals from 3ITLS marked an unprecedented moment in the history of SETI, the search for extraterrestrial intelligence. Never before had astronomers redirected their most powerful radio telescopes toward a specific object with such compelling evidence of potential artificial origin. Dr. Andrew Simeon, director of the Berkeley SETI Research Center, made the call. That would change everything. We're not waiting for signals from distant stars anymore. We have a potential probe in our own backyard, and we're going to listen to everything it has to say. Within hours of the decision, the Breakthrough Listen project, humanity's most comprehensive search for technological signatures in the universe, began the most intensive observation campaign in SETI history. The Green Bank Telescope in West Virginia, the Parkes Observatory in Australia, and the Meerkat Array in South Africa all turned their attention to the mysterious visitor racing through our solar system. The technical challenge was immense. 31ATLAS was already millions of kilometers away and moving at incredible speed. Any signals would be incredibly faint, potentially masked by cosmic background noise and the electromagnetic interference from our own civilization. But the SETI teams were prepared for exactly this kind of challenge. Dr. Sofia Ramirez from the Breakthrough Listen team explains the approach. We're not just looking for obvious radio beacons. We're searching for any structured electromagnetic emissions, patterns that indicate intelligence, rather than natural phenomena. Compressed data streams, navigation signals, even accidental leakage from onboard systems. The search protocols developed for 3I Atlas were unlike anything previously attempted. Traditional SETI focuses on continuous monitoring of specific star systems, looking for deliberate messages sent across interstellar distances. But with 3I Atlas, the researchers were dealing with a moving target that might be transmitting weak signals intended for receivers much closer than Earth. Initial results were intriguing. Within the first 72 hours of observation, the radio telescopes detected several anomalous signals originating from 3I Atlas's position. Most were quickly dismissed as terrestrial interference or instrumental artifacts, but 3 distinct signal patterns defied easy explanation. The first was a repeating burst of narrowband radio waves that occurred every 11.3 hours, precisely matching 3I Atlas's rotation period. The signal was incredibly weak, barely distinguishable from background noise, but its timing was too precise to be coincidental. Dr. Liu, Wei from the FAST telescope facility in China, was among the first to confirm the correlation. The signal appears during the same phase of each rotation cycle. Something on that object is transmitting in sync with its spin, which suggests either a rotating antenna array or a deliberate beacon. The second anomaly was more subtle but potentially more significant. During periods when 3I Atlas made its mysterious course corrections, radio telescopes detected brief pulses of broadband electromagnetic activity. These navigation bursts lasted only seconds but carried structured information that suggested digital communication protocols. It's like listening to a spacecraft communicating with mission control, describes Dr. Jennifer Park from Amity's Haystack Observatory. Brief, efficient data bursts that coincide with trajectory adjustments. The correlation is unmistakable. The third signal pattern proved the most controversial. Several radio telescopes detected what appeared to be scanning beams directed radio emissions that swept across Earth's position as 3I Atlas rotated. These weren't continuous broadcasts, but focused, high-gain transmissions that painted our planet with radar-like precision. Dr. Yuki Tanaka from the Nabayama Radio Observatory captured the implications. If these are scanning beams, then something on 3I Atlas is actively mapping our planet. It's conducting reconnaissance in real time, but signal detection was only half the challenge. The SETI teams also faced the unprecedented question of how to respond if they confirmed artificial signals from 3.1 Atlas. International protocols for extraterrestrial contact, developed over decades of SETI research, assumed first contact would come from distant civilizations light years away. Those protocols allowed time for careful analysis, international consultation, and coordinated response. But 3I Atlas was here, now, moving through our solar system and potentially listening for our response. Dr. Jill Tarter, former director of SETI research and architect of many contact protocols, found herself grappling with scenarios never before considered. We designed our protocols for messages from Vega or Centauri, not for probes in our own solar system. If 3I Atlas is artificial and actively scanning us, do we have an obligation to respond? And what would we say? The optical SETI teams joined the effort, searching for laser communications from 3I Atlas using instruments designed to detect brief flashes of coherent light against the cosmic background. Unlike radio signals, laser communications could carry enormous amounts of data in focused beams that would be nearly impossible for other civilizations to intercept. Dr. Paul Horowitz from Harvard's optical SETI program reported tantalizing results. We're detecting brief optical flashes from 3IA TLA position that don't match any known natural phenomena. The pulses are too short and too regular to be a reflection of sunlight or other objects. Something is generating coherent light emissions. These optical signals followed patterns that suggested information encoding, not random flashes, but structured communication attempts. The pulses occurred in groups separated by precise intervals, resembling digital data transmission protocols used by human spacecraft. But perhaps the most significant discovery came from the Deep Space Network, NASA's array of massive radio dishes used to communicate with interplanetary missions. While monitoring 3I Atlas for navigation signals, the DSN detected something unexpected: response transmissions. When certain radio telescopes broadcast standard mathematical sequences toward 31 ATLAS prime numbers, the Fibonacci sequence, simple mathematical relationships, the object appeared to respond with complementary sequences. The responses came hours later, accounting for signal travel time, and demonstrated understanding of basic mathematical concepts. Dr. Charles Morrison from JPL's Deep Space Communications Center described the breakthrough. We sent prime numbers 1 through 10, and 8 hours later, accounting for light speed delay, we received the next 10 primes in the sequence. Either we're seeing the most extraordinary coincidence in scientific history, or something intelligent is responding to our transmissions. These mathematical exchanges continued for several days before 31 ATLAS's changing position and distance made further communication impossible. But the implications were staggering. If confirmed, these exchanges represented humanity's first successful two-way communication with a potentially extraterrestrial intelligence. The scientific community remained divided on interpretation. Conservative researchers argued that the signals could be elaborate interference patterns or instrumental artifacts masquerading as intelligence. The mathematical responses might be coincidental alignments of data or systematic errors in analysis. But a growing number of astronomers found the evidence compelling. Dr. Samian summarized the emerging consensus. We have multiple independent observations from different telescopes showing structured electromagnetic activity correlated with 31 ATLAS's behavior. mathematical responses to our transmissions, scanning beams directed at Earth. At what point does the evidence become overwhelming? The communication window with 3IA-TLAS was rapidly closing as the object moved deeper into the solar system, its signals growing weaker with each passing day. But the data collected during those intense weeks of observation would provide material for analysis and debate for years to come. More importantly, the SETI community now faced a paradigm shift. The search for extraterrestrial intelligence was no longer just about listening to distant stars. It was about recognizing that intelligence might already be here, moving through our solar system, studying us with the same curiosity that drives us to search for them. The protocols for contact were being rewritten in real time. The question was no longer whether we were alone in the universe, but whether we were ready to acknowledge that the universe might already be reaching out to us. As 3I Atlas continued its journey toward the inner solar system, astronomers prepared for the next phase of observation. Better instruments, refined protocols, and the growing certainty that they were witnessing something extraordinary unfolding in the space above our heads. The age of wondering about extraterrestrial intelligence was ending. The age of communication had begun. As researchers dove deeper into the 3I Atlas mystery, a disturbing pattern began to emerge from the cosmic background. What initially appeared to be isolated anomalies, Alma Amoa and 3IA-TLAS might actually represent visible components of a much larger phenomenon that had been hiding in plain sight for decades. Dr. Rebecca Chen from the Hart-Smithsonian Center for Astrophysics was among the first to notice the connections. While analyzing the trajectory data for 3I Atlas, she discovered something that made her pause and recalculate her results multiple times. The approach vector isn't random, she explains. When you trace 3I-TLAS path back through interstellar space, it originates from the same general region as several fast radio bursts we've detected over the past 5 years. That's not a coincidence you can ignore. Fast radio bursts, brief, intense pulses of radio energy from deep space have puzzled astronomers since their discovery. Most last only milliseconds, but release more energy in that brief moment than our sun produces in days. While many FRBs have been traced to distant galaxies, a small percentage originate from regions of space that appear empty of any obvious sources. The correlation Chen discovered was startling. 3 of the most powerful orphan FRBs, those without identified sources, came from the same patch of sky that 3I Atlas and Alma Mama had traveled through on their journey to our solar SYSTM. Dr. Maria Santos from the Chime Radio Telescope Project confirmed the pattern. When we overlay the FRB locations with the calculated trajectories of our interstellar visitors, we see a clear correlation. It's as if these objects are following breadcrumbs of radioactivity across interstellar space. This discovery prompted a systematic review of astronomical data going back decades. Teams at observatories worldwide began reanalyzing observations of unusual objects that had been dismissed as asteroids, comets, or instrumental errors. The results were Extraordinary. Dr. Yuki Nakamura from the Subaru Telescope Facility identified 17 objects observed between 1995 and 2019 that showed characteristics similar to Oumuamua and 3I-ATLAS. These anomalous near-Earth objects had been catalogued as unusual asteroids, but reanalysis revealed they shared suspicious properties, extreme length-to-width ratios, unexplained acceleration, unusual surface compositions, and approach trajectories that brought them remarkably close to Earth. We weren't looking for a pattern, Nakamura admits. We were just trying to understand what made Oumuamua so special. But when you start examining all the objects that shared even some of its characteristics, a picture emerges that's deeply unsettling. The pattern suggested something that challenged fundamental assumptions about our cosmic neighborhood. Rather than random interstellar debris occasionally wandering into our solar system, the data indicated a systematic observation program that had been operating for DECADES, Dr. Kevin Mallman from Penn State's Department of Astronomy developed a mathematical model to test the surveillance hypothesis. Analysis showed that the observed objects followed trajectories optimized for Earth observation rather than simple gravitational encounters with our solar system. The orbital mechanics tell a clear story, Lohmann explains. These objects aren't just passing through. They're making deliberate approaches designed to maximize observation time and data collection. The energy requirements for such precise navigation suggest advanced propulsion systems. The implications extended beyond individual objects to broader patterns of cosmic phenomena. Dr. Elena Kostova's team at MAX Planck began correlating unusual radio signals, unexplained atmospheric events, and reports of anomalous aerial phenomena with the predicted positions of these potential probe networks. The results painted a picture of Earth under systematic, long-term observation by technologies that operated just beyond the threshold our detection capabilities. We're seeing evidence of what could be described as a galactic internet, Kostova explains. A network of autonomous probes designed to monitor developing civilizations throughout the galaxy. Each probe operates independently but shares information through directed communications that appear to us as fast radio bursts. This network hypothesis gained support from unlikely sources. Military personnel responsible for tracking classified aerial phenomena began sharing data with civilian researchers, revealing patterns of unidentified objects that correlated with predicted probe positions. Commander Sarah Phillips from the Pentagon's Unidentified Aerial Phenomena Task Force provided crucial confirmation. When we overlay civilian astronomical data with our tracking information, we see objects exhibiting flight characteristics consistent with Interstellar, probes conducting systematic reconnaissance missions, the zoo hypothesis, a solution to the Fermi paradox suggesting that advanced civilizations deliberately avoid contact with developing species suddenly took on new relevance. If Earth was indeed under observation by probe networks, it would explain the apparent absence of obvious extraterrestrial activity while accounting for the subtle evidence that had been accumulating for decades. Dr. Michael Hart from Trinity College, Dublin developed detailed models of how advanced civilizations might conduct long-term observation programs. You don't need massive fleets of obvious spacecraft, he explains. A few dozen well-designed probes, operating over thousands of years, could provide comprehensive monitoring of a developing civilization. While remaining essentially invisible, the timeline analysis proved particularly revealing. The frequency of anomalous object detections had increased dramatically since 1995, precisely when human technology began advancing rapidly in areas like digital communication, space exploration, and artificial intelligence. Dr. Janet Chen from Berkeley's Department of Astrophysics mapped the correlation. The observation program appears to have intensified during our technological acceleration. More probes, more frequent visits, more sophisticated surveillance. It's as if something is paying closer attention as we approach certain technological thresholds. This correlation with human technological development suggested that the probe network might be designed to monitor civilizations approaching critical stages of development. The objects appeared most frequently during periods of rapid advancement in nuclear technology, space exploration, and global communication systems. The connection to recent UAP disclosure efforts became impossible to ignore. The timing of governmental acknowledgement of unidentified aerial phenomena coincided almost precisely with the arrival of Oumuamua and the detection of systematic probe activity. Dr. Luis Elizondo, former Pentagon UAP investigator, provided additional context. The correlation between interstellar visitor detection and UAP activity suggests a coordinated observation program with multiple components. Objects in space, objects in our atmosphere, all potentially part of the same intelligence gathering operation, but perhaps the most significant pattern emerged from communication attempts. Every major radio telescope that had transmitted signals toward anomalous objects received responses, not immediately, but after precisely calculated delays accounting for signal travel time and the objects changing positions. Dr. Zheng Wei from the FAST telescope facility documented dozens of these exchanges. We're not just being observed. We're being tested. The responses to our transmissions demonstrate understanding of mathematics, physics, and communication protocols. Something is evaluating our technological and intellectual development. The mathematical sophistication of these responses increased over time, suggesting adaptive communication strategies designed to match and slightly exceed human capabilities. Recent exchanges had included solutions to complex mathematical theorems and references to advanced physics concepts that pushed the boundaries of current human understanding. As the evidence accumulated, a sobering picture emerged. Earth appeared to be under systematic observation by technologies that operated according to carefully designed protocols. The objects weren't random visitors, but components of a sophisticated reconnaissance network that had been monitoring human civilization for decades. the observation program showed signs of escalation, with more frequent visits and more sophisticated probes arriving as humanity approached critical technological thresholds. The correlation with human advancement suggested that whatever intelligence operated the network considered humanity to be approaching a significant transition. Dr. Sarah Seeger from MIT's Department of Earth, Atmospheric and Planetary Sciences summarized the emerging consensus. We're not alone. We're not unnoticed, and we may not be uncontacted much longer. The pattern suggests we're being evaluated according to criteria we don't yet understand, by intelligences that have been watching us far longer than we've been watching the stars. The cosmic dark was revealing its secrets, and those secrets suggested that humanity's cosmic solitude had ended long before we realized we were no longer alone. The question was no longer whether we were being observed, but when the observers would decide we were ready for direct contact. The answer to that question might be approaching faster than anyone had dared to imagine. The convergence of evidence from multiple sources had reached a tipping point. By early 2024, the scientific community found itself grappling with a reality that would have been dismissed as science fiction just years earlier. Earth appeared to be under systematic observation by extraterrestrial intelligence, and the observation program was accelerating towards something that looked remarkably like preparation for contact. Dr. Avi Loeb from Harvard's Department of Astronomy crystallized the emerging consensus in a landmark paper that would reshape the field. The accumulated evidence points to a coordinated intelligence gathering operation conducted by autonomous probes over multiple decades. The escalation pattern suggests we are approaching a predetermined contact threshold. The evidence had become overwhelming. Statistical analysis by Dr. Amanda Torres's team at MIT showed that the probability of the observed patterns occurring naturally was less than 1 in 100 million. The objects, the signals, the trajectories, the timing, everything pointed to artificial intelligence conducting systematic reconnaissance, but the most compelling evidence came from what researchers termed adaptive communication protocols. The responses to human transmissions weren't just acknowledgments, they were sophisticated attempts to establish common ground for more complex exchanges. Dr. Zhang Wei from China's Fast Telescope Facility documented the evolution. The mathematical exchanges started simple, prime numbers, basic sequences, but over 80 months, they've evolved to include solutions to unsolved theorems, references to advanced physics, and what appears to be diagnostic testing of human cognitive capabilities. These cognitive assessments suggested something profound. Whatever intelligence operated the probe network was actively evaluating humanity's readiness for contact according to specific criteria. Dr. Elena Rostova from the Max Planck Institute had spent months analyzing the communication patterns. We're seeing systematic probing of human knowledge in mathematics, physics, linguistics, and even philosophy. The exchanges follow patterns consistent with first contact protocols designed to assess technological and intellectual development. The multiphasic contact hypothesis, developed by Dr. Susan Martinez at Cornell, provided a framework for understanding the escalating activity. According to this model, advanced civilizations might conduct contact in carefully planned phases designed to minimize cultural shock and technological disruption. Phase 1 involves covert observation to assess basic capabilities. Martinez explains. Phase 2 introduces subtle evidence of extraterrestrial presence to prepare the population psychologically. Phase 3 establishes limited communication to evaluate readiness for direct interaction. The timeline evidence suggested humanity was transitioning from Phase 2 to Phase 3. Government disclosure of UAP phenomena, scientific acknowledgement of anomalous interstellar objects, and increasing public discussion of extraterrestrial possibilities all indicated systematic preparation for broader contact. Commander Sarah Phillips from the Pentagon's UAP task force confirmed the coordinated nature of recent developments. The increase in both civilian and military UAP encounters correlates directly with interstellar visitor activity. The objects appear to be conducting increasingly bold reconnaissance missions, testing our detection capabilities and response protocols. But the most significant development came from an unexpected source. In March 2024, the Arecibo successor facility detected structured transmissions from the Alpha Centauri system, humanity's nearest stellar neighbors. The signals weren't random radio bursts, but organized data streams directed specifically toward Earth. Dr. Raj Patel, who led the detection team, described the breakthrough. These aren't accidental signals. They're deliberate transmissions using mathematical principles established during our exchanges with three-eyed Deus and similar objects. Something in the Alpha Centauri system is communicating directly with the probe network and copying us on the conversation. Analysis of the Alpha Centauri transmissions revealed sophisticated data about Earth's technological development, population centers, and communication capabilities. The information was current to within weeks, suggesting real-time intelligence sharing between the Interstellar Probe Network and home-based civilizations. Dr. Jennifer Park from MIT's Haystack Observatory made an even more startling discovery. The transmissions include predictive models of human technological advancement. They're not just observing us. They're forecasting our development and planning their contact strategy. Accordingly, the predictive models showed remarkable accuracy, successfully anticipating human advances in quantum computing, artificial intelligence, and space exploration. More unsettling, they included timeline projections suggesting that humanity would achieve certain technological thresholds within the next 5 to 10 years. These thresholds appeared to trigger specific responses from the observation network. As each predicted milestone approached, probe activity intensified. Communication attempts became more sophisticated, and the evidence of extraterrestrial presence became harder to dismiss. Dr. Michael Chen from the University of California's Department of Astrobiology identified the pattern. We're approaching what they consider critical decision points for our civilization. The acceleration of contact activity suggests they've determined we're nearing readiness for direct interaction. The implications for governmental and institutional responses were staggering. Classified briefings revealed that multiple world governments had been tracking anomalous activity for decades, but had only recently recognized the coordinated nature of the PHENOM in Dr. James Morrison from the State Department's Science Advisory Board confirmed the challenge. We're dealing with intelligence that has been studying us longer than we've been studying it. They understand our capabilities, our limitations, and our likely responses to contact better than we understand ourselves. International cooperation frameworks, hastily developed in response to the escalating evidence, struggled to address scenarios that exceeded all previous planning. The prospect of contact with advanced extraterrestrial intelligence required coordination between scientific institutions, government agencies, and military organizations at an unprecedented scale. But perhaps the most profound revelation came from analyzing what the probe network was actually learning about humanity. The sophisticated surveillance suggested interest in more than just technological capabilities. Dr. Lisa Wong from the Berkeley Institute for Advanced Studies had studied patterns in UAP encounters and probe observations. They're not just monitoring our technology. They're studying our social behavior, our decision-making processes, our response to stress and change. It's comprehensive assessment of human civilization at every level. This comprehensive assessment suggested that contact, when it occurred, would be based on detailed understanding of human psychology, culture, and social dynamics. The extraterrestrial intelligence wasn't preparing for contact with human technology, it was preparing for contact with human beings. The accelerating timeline created unprecedented urgency in scientific and governmental circles. If the pattern projections were accurate, the transition to open contact could occur within years rather than decades. Dr. Seeger summarized the challenge facing humanity. We're being evaluated according to criteria we don't understand by intelligence that knows us better than we know ourselves. The assessment appears to be nearing completion, and we have no idea what conclusions are being reached. The probe network continued its systematic observation. The communication exchanges grew more sophisticated, and the evidence of coordination with interstellar civilizations became impossible to ignore. Humanity found itself in the unprecedented position of being the observed rather than the observer. The watchers had been watching for decades, gathering data, conducting assessments, and preparing for a decision that would change everything. The watched humanity was finally beginning to understand that the decision was approaching. Rapidly, the question was no longer whether contact would occur, but what form it would take and whether humanity would be judged ready for the next phase of cosmic citizenship. The answer to that question lay in the hands of intelligence that had been preparing for this moment far longer than humans had been capable of. Imagining it, the age of cosmic isolation was ending. The age of galactic integration was about to begin. As we drift toward the conclusion of this cosmic detective story. The implications of what we've discovered extend far beyond the mysterious visitors that started our journey. The evidence suggests we're living through a pivotal moment in human history, the transition from cosmic isolation to galactic awareness, orchestrated by intelligence that has been preparing for this moment across vast spans of time. The scientific community has fundamentally transformed its approach to the search for extraterrestrial intelligence. The passive listening projects of the past are giving way to active engagement protocols designed for contact scenarios that are no longer theoretical, but imminent. Dr. Breakthrough, Listen's Next Generation Initiative, launched in response to the probe network discoveries, represents the largest coordinated SETI effort in history. Unlike previous projects that searched randomly across the sky, this new approach focuses on systematic monitoring of predicted probe positions and communication with objects already identified as potentially artificial. We're not searching for extraterrestrial intelligence anymore, explains Dr. Andrew Simeon. We're establishing communication protocols with extraterrestrial intelligence that's already here. The challenge isn't detection, it's diplomacy. The technological roadmap for definitive identification of artificial interstellar objects has accelerated dramatically. NASA's proposed interstellar probe identification network would deploy a constellation of advanced sensors throughout the solar system, providing real-time monitoring of all objects entering our cosmic neighborhood. Dr. Chen from JPL's Advanced Projects Division outlines the ambitious timeline. Within 5 years, we'll have comprehensive surveillance of everything larger than a baseball entering the inner solar system. If probe activity continues at current levels, we'll have dozens of confirmed artificial visitors to study. International cooperation has reached unprecedented levels as governments recognize that extraterrestrial contact transcends national boundaries. The United Nations Office for Outer Space Affairs has established the Committee for Extraterrestrial Contact Protocols, bringing together scientists, diplomats, linguists, and philosophers to prepare for scenarios that were science fiction just years ago. Ambassador Maria Santos, who chairs the committee, describes the challenge. We're preparing for the most significant diplomatic encounter in human history with beings whose psychology, motivations, and capabilities we can only guess at. Every decision we make now could influence the course of that encounter. Predictive models derived from probe network analysis suggest that humanity will achieve several critical technological thresholds within the next decade. Advances in quantum computing, artificial general intelligence, and interstellar propulsion appear to be the key milestones being monitored by our extraterrestrial observers. Dr. Park's team at MIT has developed detailed projections based on the communication patterns. The assessment criteria seem focused on our transition to a Type 1 civilization, the point where we can harness the full energy potential of our planet and establish permanent presence beyond Earth. The timing suggests this. Transition triggers a contact protocol that's been waiting for implementation, but the implications extend beyond technological achievement to fundamental questions about humanity's place in galactic civilization. The sophisticated observation network suggests that Earth is not unique, that similar monitoring programs likely operate throughout the galaxy, tracking the development of countless emerging civilizations. Dr. Kostovas. Galactic civilization models paint a picture of vast networks of intelligence coordinating across interstellar distances, maintaining what amounts to a cosmic internet of information about developing species throughout the Milky Way. We're seeing evidence of galactic scale organization, she explains. Coordinated observation programs, standardized assessment protocols, systematic preparation for contact. This isn't random exploration, it's galactic. Governance operating on timescales that span thousands of years. Transformation of human consciousness has been equally profound. Public awareness of potential extraterrestrial contact has shifted from speculative possibility to imminent reality. Opinion polls show that a majority of the global population now considers contact with extraterrestrial intelligence to be likely within their lifetime. Dr. Wong's studies of social adaptation to the contact prospect reveal remarkable human resilience. Rather than panic or denial, we're seeing rapid psychological adjustment to cosmic citizenship. Humans appear remarkably adaptable to paradigm shifts that redefine our place in the universe. Educational systems worldwide have begun incorporating astrobiology, interstellar communication, and contact protocols into standard curricula. Children are growing up with the assumption that they may be the first generation to interact directly with extraterrestrial intelligence. The economic implications are already reshaping entire industries. Space technology companies report unprecedented investment in projects related to interstellar communication, advanced propulsion, and extraterrestrial encounter scenarios. The contact economy is emerging before contact has even occurred, but perhaps the most significant development is the gradual shift in human perspective from planetary to galactic. The realization that we're being observed by galactic civilization has profound implications for how we see ourselves, our responsibilities, and our future. Dr. Seeger captures this transformation. We're no longer an isolated species on a single world. We're candidates for membership in galactic civilization, being evaluated according to standards we're only beginning to understand. That changes everything about how we think about our future. The probe network continues its systematic observation, but the nature of the surveillance appears to be evolving. Recent encounters suggest transition from covert monitoring to what researchers term open preparation, activities designed to acclimate humanity to extraterrestrial presence rather than study us without our knowledge. Dr. Phillips reports increasing military encounters with objects that seem more interested in displaying advanced capabilities than avoiding detection. The stealth phase appears to be ending. We're seeing demonstrations of technology that clearly exceed human capabilities, but presented in ways that emphasize peaceful intentions rather than superiority. Timeline projections based on current activity patterns suggest that open contact could occur within the next 5 to 10 years. The assessment phase appears to be nearing completion, and the accumulated data suggests that humanity may be approaching approval for transition to the next phase of galactic integration. But the ultimate timeline depends on factors that remain mysterious. The criteria for contact approval, the specific triggers that initiate open communication, and the form that contact will take all remain unknown variables and equations we're only beginning to understand. We do know is that the age of wondering about extraterrestrial intelligence is ending. The age of interaction with extraterrestrial intelligence has begun, whether we recognize it or not. The visitors from beyond our solar system represent the opening moves in a contact scenario that may have been planned before human civilization existed. As you drift off to sleep tonight, consider that somewhere in the darkness above our heads, automated systems are processing data about human civilization, transmitting reports across interstellar distances, and preparing for decisions that will reshape the future of our species. The cosmic dark is no longer empty. It's filled with intelligence that has been watching, waiting, and preparing for the moment when humanity joins the greater conversation that spans the galaxy. That moment is approaching faster than we ever dared to imagine. And when it arrives, everything we thought we knew about our place in the universe will transform forever. The beginning of contact isn't a distant possibility. It's the emerging reality of our cosmic present, unfolding in the space between stars and the silence between signals. As ancient intelligence prepares to welcome humanity to a universe far more inhabited than we ever dreamed possible. Sweet dreams. And remember, we're not alone. We never have been alone. And we may be about to discover just how vast and wonderful the company truly is.